Well, Professor Hannan said that there would be many people here who knew a lot about what he's been talking about. There were many experts present. I have to hurry to say that I'm not one of those experts. I am the interested amateur who will come with some thoughts on what has been said. Professor Hannan starts in his paper by stating some facts about the approximative nature of his work and that the models should be local in time in order to take care of nonlinearities. And therefore we will have structures that are changing. And I think that it is very important to realize these things, and that is also what was important in the remarks on the recursive nature of the estimations. So my comments will rely on or will relate to these facts. Professor Hannan's paper had these 5 chapters, and I will basically talk about the assumptions that are made in the section on the linear systems, and then the future work that may be done will of course fall within these areas. Now, since I am an amateur, I start, when I get such a paper, by writing up the models. When I see a vector or a matrix, I prefer to see the individual elements, so I started writing things up like this. But, well, this is just one formula in a 20-page paper, so you'll very soon get a lot of pages in this way. And then I got a letter. I don't know whether it was also sent from God or how Tarmo knew that this was my line of work, but he sent me the definition of a discussant, and that is a person who is putting the entire audience to sleep by going on and on about that fellow's paper. And in order to avoid that, I'll not continue that line of trying to make you understand what I understood from reading the paper. Now, the parameterizations that Professor Hannan were talking about depended on a selection of rows in the predictor space defined by the Hankel matrices. And that gives a so-called canonical parameterization. This may, from a practical point of view, be a less suitable type of parameterization because you have to determine the invariance from the data, and the estimation of that is very crucial for your analysis, and your parameter estimates may be all wrong if you are making a mistake here. And therefore, you may consider other types of parameterizations. Now, the parameter, put in a mathematical term, is equivalent to cover a set of all possible states or a quotient space with coordinate systems. And the canonical forms are composing coordinate systems that are not overlapping. But you may also choose overlapping forms. And if you do that, then you may, in fact, do some online structure estimation. And that has been described in a paper by Overbeck and Jung. And these non-overlapping forms have also been described by Professor Hannan, of course, and others of the people present. But I think that this other type of parameterization, the overlapping forms, is very useful from a practical point of view, and I think that one should consider using stuff like that as well. So although the other type of parameterization is called canonical, I mean, then it is not necessarily optimal when you want to apply it. And there may be other drawbacks. If you find a canonical armor model, or if you obtain a canonical armor model from this canonical matrix fraction description that also was mentioned shortly, then we have a lot of drawbacks here, and that could definitely influence the use of armor models in identification and control. And in a very recent volume of International Journal of Control, from some of those people who are stealing statistical time series, a paper by Boker and Kevitsky, they are, instead of building their ARMA canonical forms on this matrix fraction description, they are instead using some constructibility invariance, and that amounts to, instead of describing or observing the state from future outputs, you will observe them from the past recent outputs. And I think that going on along that line may also help a lot in practical work. Of course, you pay something for this. You may have no poles at the origin in order to invert the matrices involved. But a lot of the previously mentioned disadvantages will disappear in that way. And I think that in conclusion, you could say that Professor Hannan has definitely presented a very stimulating and interesting paper, and it suggests an enormous amount of future work. The field is very important. I have a but to put there. When I received the paper, it had a reference, and the reference was to a book by Professor Deisler and Professor Hannan, and I guess that it may give you answers for a lot of the questions one wants to pose on the statistical analysis of linear systems. Thank you.